Let's start projectile motion. If you throw a rock in the air with this velocity, let's say like this, the rock is not going to continue going on this direction. The rock is going to go like this, right? So every point of this movement, every point of it has its own velocity, and the next point has its own velocity, another velocity, and every point. So let's say if I don't take every point, I just take every few other points, like this would be how you can show the velocity. And in every single point, the velocity would be on a tangent, and you know what is tangent? Tangent is a line that meets the curve only in one point. I don't care about this part because I'm only caring about the direction of the direction of the movement shows my velocity, so my velocity would be in this case here, right? So this is how it works. And let's say if this is my velocity, let's say initial velocity, I'm going to draw it from here. This initial velocity can be, and you remember the word Hamsang I told you, which means equivalent vectors. So I can draw my vectors from anywhere. This is my velocity, my initial velocity. Right now I want to ask you a question. When this rock is on the ground, you are pushing, you're throwing it, right? But as soon as the rock leaves your hand, then the push of your hand is not behind it anymore. So it has an initial velocity because your initial force, but your initial force is gone. So while this rock is traveling in the air, separated from your hand, there is not a force from your hand applied to it, nothing. And the air resistant, you also take it as negligible, really. So what are the other forces that can be applied for this can be applied to this moving rock? Stop the video and answer this question. What other forces are involved? Okay, of course the answer is there is only one force affecting this while flying on the air, and that force is the force of gravity, its own weight, which is dragging it down all the time is trying to drag it down, right? Is a downward force, and so it's trying to drag it down, and you know that the force causes acceleration. So the acceleration of gravity, which we know is actually negative 9.8, which we usually consider it as 10, almost 10. So this is the gravity, meter per second square. So this acceleration of gravity is going to affect this, and you know that the v equals v initial plus at. So for a given time of t, let's take t as 1. If I take t 1 second, then v would be vi plus a, right? So the vector a, I just wanted to make it simple so I can explain it easier. So the vector a is here, moving towards, trying to drag it down, and you remember adding the vectors together. In here we have vectors being added together, right? If I want to show it like this, would be even best. This is also vectors. So you remember triangle method of adding vectors together? This would be my other v after 1 second, let's say. Actually, I'm going to just draw the v's of every second. I mean, in the end of every second, so not all the time within each second, just each second. Let's, for example, if this is my, let's say this is my v initial. After 1 second, let's say this a is added to it, so this would be my other v, which I draw it from here, because you know these are the same vectors. They are just you know how the vectors are equivalent, and you can draw them from anywhere. So, and the next vector, let's say this one, this A is affecting it, so this would be the next vector. I draw it from here. This is this one, so this is velocity at this point. This is another velocity. Another velocity, again, this A is affecting it, so this is coming like this. So this would be the other velocity after. So this is the velocity in the beginning. This is after 1 second. This is after the second. This is after the end of the third second. And this is after the, you draw this A here. So this would be after the end of the 1, 2, 3, 4, the end of the 4th second. And this is after the, you draw this, and this would be the other one, which this is the after the, this is after the end of the 5th second. If I am, there is definitely a symmetry in here, so I'm going to draw it a little bit better so you can see the symmetry. This is VI. This is after this. These are the other V's, as you can see. They're going to be like this actually. This must be. There must be a symmetry in here, just the direction is this way, and this one is like this, and this one, so it's gonna be something like this. I'm gonna something like this maybe. Yeah, and this is not the real movement, as you know. All of all the velocities, like every point has its own velocity, just that I am showing it like this so it's easier to explain. Now you can go to the next video to understand what I am trying to say.